welcome back to second part of lecture 7, and we have been discussing about the ceramics and polymers. Mostly in the last part of the lecture part 1 I was talking about polymers, and there I talked about crystalline and amorphous. So, let us try to understand more what is amorphous. And if you want to understand amorphous, first thing to see is the window glass. You have probably seen in many of the windows, whether it is a house window or a car window, you have glasses, and they are important part of our materials world. We cannot do anything but replace these glassy things. Why they do? Because they are transparent to light, that is why. And we know why they are transparent to lights, because they do not scatter light much, they rather allow the light to pass through. So, there is something which is unique to this material, the structure. In crystalline materials, atoms are arranged in a definite order, right. You can see here atoms are arranged in a definite order, right. You can see that. You can see here hexagon structure, right. I have drawn. This is the hexagon. This is the closest packing possible in hexagon. But in a haphazard arrangements of atoms, there is no such arrangement is possible. That is what is called amorphous. Amorphous means there is no specific order arrangement of the atoms. That is the first thing you should realize when you compare crystalline with amorphous. Crystalline materials have order arrangement of atoms, nicely packed. You can see the packing on the left side, the nicely packed hexagonal array, so that each atom touches each other or surrounded by other atoms, and that is the feature of crystalline materials. Amorphous materials, you can see there are a lot of free spaces and atoms are arranged in a haphazard manner. There is no order. To give you more perspectives, this is something I took it from the Michael Ashby's book, very important things to understand. So, this picture on the left hand side, top picture, this is nothing but a order arrangement of atoms, and we talked about it, right. We have discussed about it. These are the grains, and in between the grains there are grain boundaries, right. And I told you that along the grain boundaries, atomic arrangement is not like what is inside the grains. You can clearly see in the inside the grains nice hexagonal arrangement of atoms are present as shown in this picture. But on the other hand, atoms along the boundaries are not following any arrangements, they are rather random or haphazard. So, therefore, these boundaries compared to these are the boundary, you can see this is the boundary shown here, another one here. These boundaries actually indicate that atomic arrangement is possible for the material to be random or haphazard. Now can you make this arrangement all pervasive throughout the whole material? That is what is shown on the right hand side picture. You can see what is written as a total disorder. There is no order of atoms, any way you cannot do any order of atom, ordering of arrangements of atoms. They are a complete disarray. That is why it is called amorphous. Okay. This word you should remember, amorphous. Okay. And so, in contrast to crystalline, this is the structure of amorphous. Since atoms are not in order arrangements, so therefore, what is the thing actually you will see? Properties will change definitely. Here atoms are ordered nicely except at the grain boundaries, but here atoms are ordered haphazardly, there is no grain boundaries here. Since there are no boundaries, that is why light does not scatter, because light can easily pass through the glasses. This is the main reason. There are many other reasons, but this is one of the main reasons actually. So, light can easily transmit to the glasses without much bending, and that is why you use glasses. Remember this. Glasses are very important, even my specs has a glass, right. So, we have been using glasses for ages, but only fundamental understanding of glasses came in last 100 years. So, like window glass is made up of 3 oxides, they are made up of 3 oxides, one is sodium oxide. So, first one is Na2O, then you have CaO, calcium oxide, and then you have silicon dioxide. These are 3 constituents of the window glass which use on the windows and they are present predominantly in the earth's surface. In fact, this glass was discovered serendipitously. I talk about serendipitous discovery, discovered serendipitously on the coast of West Indies by the mariners. Some sheep actually went there and they were hitting, they are actually making food, and while they are making food on the beaches, these constitutes melt down and form a glass, and glass is transparent to light. You immediately detect it. So, that was how it was discovered. Serendipitous discovery of glass is very, very important thing which you should read from even various kinds of information, including Wikipedia. So, glass has this random or total disordered arrangement of atoms compared to crystalline materials. In polymers, as I talked about it here, you can have both amorphous region as well as crystalline regions. Crystalline regions you understood, amorphous now you have understood. Now, that is what is shown here. This is also taken from Michael Asby's very nice, very important book on nanomaterials, nanotechnologies and design. So, you can see here these are the regions of disorder and these are the regions of order. Okay. These are the regions of order. In the middle there is a region of disorder, there is a region of disorder, there is a region of there is a region of order, there is a region of order, and other places there is a region of disorder. So, this is a polymer which contains both crystalline as well as amorphous regions, and this by this we can actually impart many kinds of properties, many kinds of important properties we can impart easily, because you have both present. Metal also it is possible to have both. Remember we discussed about glass ceramics. It is one of the classic material which was again discovered serendipitously. Glass ceramics also has glass amorphous structure in which crystals are present, and they give very many important properties. So, you can also on the other hand you can also have in polymers what is called as a total disorder, complete disorder, means no crystalline part is present, that is called completely amorphous polymer. It is possible to produce that, and that can also be transparent to light, obviously, because this is the nature of arrangement of atoms which provides you transparent light to pass through. Many water bottles are transparent to light, they are actually having amorphous polymers, but many polymers are not transparent to lights. So, they are crystalline actually, they have a lot of crystalline parts, that is why they are not transparent to light. Bakelite is basically black, you cannot see through bakelite, but polyethylene you can see through. Polyethylene sheets are actually transparent to light. So, you can understand now why these properties are coming from. The structure is underlying structure is what is dictating the properties of this. Now, polymers are very soft, you can actually pull a polymer and even tear a polymer sheets, right. Why? Because bond between these chains are very weak, they can be easily broken compared to metal and ceramics. Like this pen I cannot easily break because there is a lot of strong bonds are present, but if I take a polymeric sheet and try to pull, it will break into pieces easily. That is because they are having weak bonds between the chains, and these bonds are basically carbon, hydrogen, oxygen, nitrogen type bonds, and that is why they are weak in this kind of structures. Well, so much about polymers. Now, little bit talk about composites, and composites I already discussed, they are actually nothing but heterogeneous solids, they are not homogeneous solids. Heterogeneous solids consisting of two or more different materials that are mechanically or metallurgically bonded. They can be mechanically bonded also, but they are not good, but they are metallurgically or very nicely bonded, then it can have very good properties. Wood is nothing but a composite, bamboo is a composite, all of you know, probably you can see the fibers in the bamboo also if you cut it open. And major advantage of composites what? Because we can combine two materials, we can actually have conflicting properties such as ductility and strength together, such as both electrical and thermal conductivities together, and in addition depending on the type of material combination present, you can have low weight, high strength, high stiffness, including even creep resistance. So, this polymers actually gives us an opportunity to create new materials very easily. We can combine and create new materials, that is why you can discover any materials. But remember that polymers, when you combine these two, there will be interface between the two materials, and the properties of the weakest link of any composite is basically the interface between the two materials. and that dictates the properties. So, if you can create a strong bond between the two materials, then you can achieve very good properties, otherwise they will not. That is one of the major things. So, composites have good corrosion resistance, you can impart actually good corrosion resistance, you can impart high hardness and conductivity. Depending on the how polymers are produced, they can be laminar or layer. Plywood, you know, it is nothing but a laminar structure. Basically, this a layer of woods are bonded together with their different grain orientation at different angles. Now you understand, right? Different polymers have different rather plywoods have different kind of strengths, and in the markets you will get at different prices. That is because these grains of woods actually, or the basically powders of wood, they can be bonded together at different orientations, and then you can impart different kinds of strength and other properties. Some polymers are very some plywoods are very strong, some plywoods can be easily broken. So, therefore, we can actually improve strength and fracture toughness together in case of plywoods, and it can also reduce a swelling or shrinkage very easily. And then you can also have polymers like safety glasses. All of you know probably safety glasses, which are nothing but windshields in the car. So, you can actually place adhesive between two pieces of glass, or between two pieces of glass you can join using adhesive, and because of that, if you throw a stone or something on the windshield glasses, they will not break, rather they will crack, and when they crack, the cracks will get blunted by these adhesive layers. That is what actually windshields are cannot be easily broken into pieces. You will see the cracks formation, but it will never shatter into pieces. Obviously, if you hit very hard, it will, and if you also shoot a bullet, windshields will have a hole, it will not crack fully. That is why windshield is a composite. In fact, our safety helmets are actually also made of composites of polymer and glass fibers. That gives us a huge fracture toughness, energy absorbing ability. If it is impact loaded by some accident or something, it will not break. That is what you will see in case of safety helmets. You can have also particular composites. Actually, safety helmet actually has as an example of particular composites, in which you have discrete particles of one material surrounded by a matrix. It can be polymer or metal or ceramic matrix. An important example is a concrete. In concrete, what you have a cement, you have stones, and you have sand, and they are all different length scales. Like stones are bigger, sand particles are much smaller, and cement is nothing but a very small particle. So, when you mix them together, what do? You form a particulate composites. Each is one particulate, and matrix is nothing but that cement material. You can also have hard particle versus soft particles. You can have hard particle in a soft matrix, and you can also have soft particle in a hard matrix, both are possible. And basically, you have a lot of ways of engineering different kinds of composites. Okay, so, best example of composite is cemented carbide tool actually, which you use for as a cutting materials. You know that, what are they? They are all made of carbides, I told you, right? Tungsten carbide, tantalum carbides, or titanium carbide, very hard, extremely hard, but extremely brittle. So, what do? In order to retain the toughness, you can put these particles in a matrix of metal like cobalt or nickel, and nickel and cobalt actually are ductile. So, these carbides will be dispersed as a particle in the matrix, and that can gives you very high fracture toughness and strength. They are already very hard. So, only thing you can impart fracture toughness so they do not break into pieces. These hard steep carbide particles can withstand very high temperature, they can also very hard, so they can cut also very easily, and this toughness is imparted by the cobalt matrix. So, you can see how ingenious ways of making this kind of composites can help sustain the engineering applications. This is very important for you to understand, and this kind of design principles will be used for machine learning approaches to discover new materials. These are real examples where, without knowing machine learning, how humans have designed new kinds of materials for different kinds of applications. Well, you can also have composite materials like SiC and silicon carbon alumina as a fiber. You can put fiber also. Well, basically bamboo is nothing but a fibers composites. You have fibers which are embedded in a matrix. So, you can also use polymeric fibers like aramid fibers or some other fibers, or you can use ceramic fibers like silicon carbide fibers can be used, and matrix can be either polymer or metal. Polymers are not used at high temperatures, like they can be used at normally at room temperature or about below 300 degrees Celsius temperature. Metal matrix composites can be used at high temperatures. Well, steel reinforced composite concrete is nothing but a fiber composite. I do not know whether you have realized or not, we put steel rods in a composite, right, when you build concrete structures, and these are actually fibers, but they are very thick and long fibers, by the way, and concrete is nothing but a matrix. You can also have nylon reinforced tires. Tires can have nylon fibers that can give us a lot of strength. You can also have glass fiber reinforced plastics for car bodies or even furnitures, and all of you that know or do not know, I do not know, boron reinforced aluminum composites can be used for aircraft or rocket components. So, all these are actually produced. By the way, the light and combat aircraft, which is the main force of Indian Indian Air Force, is basically polymer composites. Polymer fibers in a polymer matrix is what is used, and so these kind of structures are nowadays very omnipresent in various kinds of applications. Sporting equipment like tennis rackets, skis, finishing rods, or even pole balls, they are made up of composite materials. So, obviously composite material the properties of composite material depends upon properties of fiber, volume fraction of the fibers, aspect ratio of the fibers, how length, diameter versus length, orientation of the fibers, whether you can put like this or like that only, different orientation possible, cross or parallel orientations, degrees of bonding between matrix and fibers, I already talked about it. The bonding between the between the matrix and the fibers is very important, and that is the weakest link actually in a composites. If that link can be strengthened, you can actually have stronger composites, and obviously properties of matrix are also going to play a very important role. I hope you are getting a complete picture of this, different kind of structures, different kind of materials like metals, alloys, polymers, ceramics and composites. I think that is good for you to learn. If you want to learn more about it, please read different books, because I am only getting there is not much time to talk about details of each of these. I am giving an overview of the different kinds of material which exist, and also different structures, how they are correlated. So, now we will talk about little bit of properties. Well, obviously little bit means small, not much, because I cannot talk properties of materials in a 3-4 lectures. That is nothing but a very simple description of the properties of materials. And important properties of material is what? Mechanical properties, strength, all of you know, right. When we move on the ground, we have our body moves actually. So, or when we play, we run, sometime actually we also apply forces. So, that is why the strength of mechanical properties are very important from the perspectives of that. But you also have other properties like physical properties like densities and chemical property like inertness, activity, these are also very important. So, first we will talk about mechanical properties. Material properties actually must be compatible with service conditions to which a component is subjected to. Also, it will be also compatible with manufacturing process by which you are making the material, making the component, because if I make a brittle material, if I deform, it will break into pieces instead of forming component, right. So, therefore, I cannot process tungsten coils which is used in the incandescent bulbs simply by the deformation, simply by applying forces. I have to use some other techniques to do that, because they are very brittle, and very high melting points are also another factor for each not to be processed by these kind of routes. So, this is very important for why we should have a good idea of the materials properties. So, when you talk about mechanical properties, what is important for you to understand what kind of loading conditions are used, whether it is tensile loading, compressive loading or shear loading. I hope you know tensile loading means you pull it up, you apply a load in the two opposite directions. Compressive means you are applying a load to press down, that is what is used. In a building, all the columns are subject to compressive loading, but in a car many of the bodies of components actually are subject to tensile loading. You can also have shear loading. Okay. Very simple example shear loading is taking taking the ear and just distort it. This is shear loading. Okay. You are twisting your ear lobe, right. That is nothing but a shear. You are applying a shear in the whole process, and shear loading is very important for material processing. We will talk about little later, sometime later, how this is important. But so mechanical properties to be discussed based on the type of loading condition. But we know in real applications all these kinds of loading conditions are present. So hence loading type is very important when you talk about it. How do you test? To give a perspective of tensile testing, which is most commonly used in the actual practice, this is called tensile testing machine, or what is called UTM, universal testing machine, which probably you have heard about it. Here you put a sample like this, which is nothing but a dog bone shaped sample, okay. And this sample is then pulled by application of forces, you can see that, correct, till it breaks or it fractures, and this gives us actually the different kinds of mechanical properties, not only strength, ductility, elastic constant, many things can be obtained from this. This is the machine which is present in any labs, whether it is industry or in academic institutes present, you can see it, and I think it is better actually you see this machine and how the test is done. So as you can clearly see that if you want to measure the strength and ductility, you need to use probes. That is what is very important. Here we are showing a probe which is called extensometer, and this probe or this device actually measure the increase of the length of the sample. When you apply a load, sample will simply deform plastically and its length will increase and width will decrease. So that has to be probed, and that is done by using extensometers. So you can see there are different kinds of geometries of that is shown. So the extensometers are attached to the sample, to the specific location of the sample. Here extensometers actually are attached, and then we can measure the ductility or the deformation ability of the material. Well, one can actually have also need to have load cells, because you are deforming a material, okay. That is why you need to know how to apply load. These are nothing but a load cells, which provides you to apply loads at different types or different amounts of loads, and extensometer, as I told you about it, this measures the ductility. So these are the two very vital parts of this kind of experimentations, which probably you have seen. So we will talk about much of these tensile tests and different kinds of material properties in the next lecture. I just wanted to give you an idea that why this is important, how this can be done. So let us stop it here. I hope you are enjoying the lectures, and I look forward to your comments and suggestions, anything. So in the next lecture we will talk details about the tensile testing. Thank you.